Hi viewers, welcome back to my class on heat transfer.
In today's class, we'll work out a numerical example on heat transfer through a composite slab.
Let us work out a numerical example. A composite wall consists of three different layers. The thickness of the inner, middle and outer layers are 20 cm, 8 cm and 5 cm respectively. The thermal conductivities of inner, middle and outer layers are 65, 1.2 and 0.08 watts per meter Kelvin respectively. If the inner and outer surface temperatures are 340 degrees centigrade and 24 degrees centigrade, find the heat flow through the composite wall. So we have a composite wall with the thickness 20 cm, 8 cm and 5 cm. And with the thermal conductivity 65, 1.2 and 0.08 watts per meter Kelvin, and temperature on either side is given. You have to find out the heat flow. So we have a 3 layers of material. So we have already derived the equation for 2 layers. If one more layer comes, you will have one more term added like this. You can draw the heat flow circuit T1, T2, T3, T4, L1 by AK1, L2 by AK2, L3 by AK3. So if you want these 2 points to be taken, temperature difference between those 2 points
divided by the summation of the thermal resistance between those 2 points,
that will give the heat flow. So only two materials, T1 minus T3 divided by L1 by AK1 plus L2 by AK2 will give heat flow. Now temperature T1 is given. Temperature T1 is 340 degrees centigrade, and other end T4, we will take this T4 24 degrees centigrade. Thermal conductivities of all the three materials: first material 65, second material 1.2 and third material is 0.08 watts per meter Kelvin. So it's an insulator. Now thickness of the first layer is 20 cm, it's 0.2 meter, and the second layer is 8 cm or 0.08 meter, and third layer is 5 cm or 0.05 meter. We have the heat transfer through the composite wall as T1 minus T4 divided by L1 by AK1 plus L2 by AK2 plus L3 by AK3. Now we can substitute that temperatures, direct substitution. Once you know the formula, direct substitution you can make. T1 is 340 degrees centigrade, T4 is 24 degrees centigrade. So L1 by AK1 is, L1 is 0.2, 20 cm is 0.2, area is unit area. Area is not given, so per unit area you should find out the heat flow. Thermal conductivity is 65. Second layer, the thickness is 8 cm or 0.08 meter. Again area is taken as unit, and the thermal conductivity is 1.2 watts per meter Kelvin. Third layer 5 cm is 0.05 and area is 1 and thermal conductivity is 0.08 watts per meter Kelvin. So substituting that, you will get the rate of heat flow as 454.844 watts. So this is per unit area of the composite wall. Per meter square area, the wall permits 454.844 watts. So every second per unit area of this composite wall will permit 454.844 joules. If you have to find out the heat flow for a longer period of time, that is for 1 hour, you should multiply with the time period, that is 3600 seconds. That will give the heat flow permitted by this composite wall in 1 hour. Thank you for watching.